Hello, algebra. So today we are talking about multiplying polynomials. I'm going to show you two different ways to start with, but I want to tell you now I'm going to stick with one of them, and I'll explain why in a minute. So we know that when we multiply polynomials, like we've got a monomial here times a monomial. So we would separate out our coefficients, which are highlighted in yellow, so we get 5 times 4. And then I always put the variables in alphabetical order. We just have x in this case, so it doesn't really matter. So I've got x squared and then x cubed. I know 5 times 4 is going to get me 20, and then because I'm multiplying these, I need to add their exponents. So I'm going to get x to the 2 plus 3, so this gets me 20x to the 5. So just a little bit of review, we already know how to do it. So what we're going to do is look at two different models, and we're going to start with this example on page 2. So we've got the area model or the distributive property. All right, those are the two. I prefer the distributive property, and I'll show you why in a minute, but the area model also works. So they are both valid. They work fine. I just want you to understand that this is how my brain works. So I'm going to show you both. Pick one. I'm going to do this from now on. So area model. The 5 is outside of our parentheses here, so there's just one term. So I have one side to my box here, so to speak. And then you can see we've got three terms, 2x squared plus x plus 4. So I've got 3 along my top, and I've separated those everywhere that there was a plus, basically. So this is really a positive x and a positive 4. Do I need to write positive on there? No, I don't. You would have to if it was a subtraction sign, but not for plus. So now inside this box, I am going to multiply, right? To find the area of something, we have to multiply the length by the width. So I'm going to multiply 5 times 2x squared. Well, I can multiply my 5 times 2, so it's going to be 10x squared, right? I'm just multiplying those terms. So for the next one, I'm going to have 5 times x. My length is 5, my width is x. And then for the last one, I'm going to have 5 times 4. My length is 5, my width is 4. So each of these boxes has its own area. That's why it's called the area model. So I'm going to find the area of each of these, and then I will add them all together at the end. So 5 times x is 5x. 5 times 4 is 20. Yes, you need to show your work. So the answer to this would be 10x squared plus 5x plus 20. All right. Do I have any like terms? No, I do not. I've got an x squared, an x. I have nothing I can add together. It is in standard form. The x squared comes first. I'm done. My leading coefficient's 10. And it's a trinomial, right? It's got 3 parts, so it's a trinomial. So that's the area model. Some of you might like that a lot. Great. If you don't, I'm going to show you my way, which is the distributive property. So the distributive property is one that you guys are probably pretty familiar with. We tend to use it a lot in math. I think it works with most of our brains. The visual of the area model is kind of nice, but I like the distributive property. So for this one, I am going to distribute my multiplying of the 5 to each of these. This would be 5 times 2x squared. And then I would have plus 5 times x plus 5 times 4. Right? I'm distributing that multiplication to each, and hopefully you can see my multiplication signs in there. Well, 5 times 2x squared is going to be 10x squared. 5 times x is 5x, and then 5 times 4 is 20. And that's my answer. So you'll notice it didn't matter which way I did it, right? It didn't matter which way I did it. I got the same answer. So cool beans, just so you're aware, doesn't matter which way you pick it, you get the same answer. Let's take a look at some other examples of this, because oftentimes we will have a binomial times a binomial. Well, what does that look like? It looks something like this. So we've got 2x plus 7, and we are multiplying that by 3x plus 7. I'm going to do the distributive property, okay? I'm also going to show you, because this is kind of weird, I'll show you the area model. Wasn't going to, but I will. So I've got, in my first parentheses here, I have 2 terms. So I need to have a box that is 2. All right, so I'm going to have 2x there, and I'm going to have my 7 there. And I'm going to draw a line separating them. And then I need to have 3x and a 7 along the top as well. Again, you can have the plus 7 on there if you want to. You don't have to. So inside each of these boxes, I'm just finding the what the area would be. So I'm going to multiply my length and my width. 2x times 3x. This would be 2x times 7. this would be, it's got a 3 and a 7, so I'm going to do 7 times 3x, and then over here would be 7 times 7. So each of my boxes has the length and the width in it. Do you see that? I'm multiplying the length and the width. So this one, I would get 2x times 3x is really 6x squared. This one's 14x, this one's 21x, and this one would be 49. Now I'm going to rewrite those all down here. So I get 6x squared plus 14x plus 21x plus 49. Do I have any like terms? Yes, I do. I have a like term right here and right here because they're both just x's. No squareds, just x's. So I'm going to leave my 6x squared, 14x plus 21x. Add the coefficients, leave the x. So I'm going to have just an x. 14 plus 21, that would be 35. And then I would get plus 49. So that is the answer for that one. I'm going to show you now the distributive property. So distributive property would be, and there's a little acronym for this. Sometimes people use it's called FOIL. I'm sure if you ask your parents or your older siblings, they're going to be like, oh yeah, FOIL. Well, FOIL stands for first, outside, inside, and last. That's what FOIL stands for. I don't know why my T's keep going in the wrong spot. So first, outside, inside, last. It helps us to remember, that way we get all of them, all right? Because you are multiplying 2 by 2, everyone knows that 2 things times 2 things gets you 4, right? 2 times 2 is 4. So you should have 4 terms when you distribute, all right? That's your check. So I'm going to do 2x times 3x first. 2x times 3x. Then I'm going to do 2x times 7. So plus 2x times 7. Oh, I need to move this down. Sorry, guys. I will move it down. So 2x times 3x plus 2x times 7. Then I'm going to do 7 plus 7 times 3x. And then plus 7 times 7. So you see how I did the first ones, the outside ones, the inside ones, and then the last ones. That's kind of how it's supposed to go. It just makes sure, again, that you get all of them. So I have 4 terms that I should be ending with. Well, 2x times 3x is 6x squared. 2x times 7 is 14x. It's a positive. 7 times 3x is 21x. And then we get 49. And again, I've got my like terms here. So I get 6x squared plus 35x plus 49. So hopefully you're feeling pretty comfortable with this. We're distributing, that's all we're doing, right? We're distributing, that's all we're doing. So let's take a look at another example, but this time let's have some negative signs in there because I think that it's really important to practice with some negatives. If I can find my example that I had picked out that has now disappeared on me and is really frustrating. Aha. There we go. So with this guy, again, you could use the area model. I'm going to stick with the distributing. All right, I'm going to stick with distributing. All right, it's just how my brain works. So for this guy, I want to do my first ones. So that'd be x times x. My outside ones, so plus x times negative 5. You have to be careful because this is a negative 5. Okay, it's a negative 5. So don't just drop that negative sign. Keep it in there. Then I'm going to do plus 2 times x, and then we'll do our last ones of plus 2 times negative 5. So just tack on that negative there, like a purse or some accessory for the 5, right? So x times x is x squared. And then I've got plus x times negative 5, which is negative 5x, plus 2x. 2 times negative 5 is negative 10. Do I have any like terms? Yes, I do. I've got these two right here. So that gets us an x squared. Negative 5x plus 2x. I'm going to have an x, right? They both have x's. Negative 5 plus 2 is the question. We get negative 3, right? Negative 5 plus 2 is negative 3. So the x just hangs out. So this is our answer. I'm going to do this one as well, again, using the distributive property. So if you ever see this, if you see x plus 5 squared, that really means that you have x plus 5 times x plus 5. Right? That's what it really means. It really means you have x plus 5 times x plus 5. So write it out, and then you can distribute that. So we get an x times an x plus x times 5 plus 5 times x plus 5 times 5. So this is really x squared plus 5x plus 5x plus 25, right? That's what it really is. I have some like terms here. So x squared, 5 plus 5 is really 10, so this would be 10x plus 25. All right? Hopefully this makes sense. Email me if you have any questions. I am happy to help.